This is the oral history of David Levy, recorded on October 3rd, 2019 at the Computer History Museum in Mountain View, and I'm Gunter Steinbach. Welcome, David, and thank you again for agreeing to donate your history to the museum.
Thank you. Pleasure.
So our first contact was when you saw your own name in another interview mentioning your role in putting touchpads into Apple products. But we will not limit ourselves to that. We want to record your complete oral history. And I expect there'll be a lot to tell because I've actually seen write-ups about you in the archives of MIT, of Fortune, and the New Yorker. So let's start with background. Where did you grow up? When, how, and your childhood hobbies maybe and exploits? What got you into engineering?
Grew up in Los Angeles in Gardena in the beginning, and there was some reason that we moved to Manhattan Beach, and spent the rest of my time there with my mom, dad, and brother, sister, and I think I had a lot of hobbies: archery, juggling, magic. I tended to try different things and move out of them, but some of them stuck. I think the ones I mentioned are the ones that stuck. Architecture was a constant. Got attracted to architecture at 13 or 14 and asked my social studies teacher if I could work for her husband. As soon as I found out he was an architect, I asked, could I work for the summer, can I work for him? And she thought it was cute. And the guy said yes. And that was my first job. I was 14 years old, and he taught me how to letter, and I knew nothing, absolutely nothing. And David McAllister set me on the road to being an architect. So by the time I was 18, I needed money to go to Europe, and sort of opened an architectural office and did a second-story addition and a church and a kitchen remodel in a very short amount of time, and got enough money to go to Europe.
Wow. So you just opened an office and hung out your shingle?
I put an ad in the local paper. I made it clear I'm not an architect. I mean, it was obvious. I was 18 years old. But I was cheap and I was fast, and so people that wanted a cheap, fast job, it was appealing. And I'm sure I was undercharging, but it was, at that point, I wasn't sleeping. I was doing nothing but working in order to finish the jobs in time and get on the plane and go to Europe.
Oh. But your degree is not in architecture.
No. I was completely convinced I wanted to be an architect. At the time, my fascination was that it was an art that you could go inside of. It was a functional art, and that appealed to me tremendously. And I was doing everything I could to support that. So I was drawing, and I worked for a contractor as a workman, because I read that Frank Lloyd Wright said that you need to understand every aspect of the job. So I did a summer as a worker doing framing. And when I got to MIT, we're sort of jumping ahead, but when I got to MIT, I learned that there was this thing called engineering. And I really had never considered it before getting to MIT. It was one of the few people that did it completely backwards. A lot of people go to MIT for engineering and end up doing other things. And I was fascinated. And at the time, what I did was I integrated. I got a dual degree between mechanical engineering and architecture. That's actually what my degree is. It's a 2A as an adjunct to the normal mechanical engineering degree, and I chose architecture.
So, how did you hit on MIT? You were on the West Coast.
Well, MIT and Berkeley were the two schools in the country that taught humanistic architecture at the time. There was a lot of formalism. Yale, Harvard, there was the classical style, neoclassical architecture, and I wasn't as interested in that. I wanted humanist design, which was more focused on human need and the environment, and the schools that were excelling in that were MIT and Berkeley. So those are the two schools I applied to.
And MIT?
Well, I made a list. I made a list of all the pros and the cons between the two schools. And as I recall, Berkeley won every category, except for one category, which was that it wasn't MIT. And I chose MIT based on just innate desire to want to be at MIT.
Was your
It was an irrational decision.
Were your parents alumni?
I'm sorry?
Were your parents alumni of MIT?
No, they were not.
So it was just you picked it up somehow.
I could not tell you the source of my affections.
Okay.
Don't know.
So can we just get your degrees, when and where you got those?
Bachelor's in mechanical engineering from MIT. In the year is a little bit of a question because I actually finished everything except one class in PE, and I didn't take it because I didn't want to graduate. So because I wanted to stay in the undergraduate dorm, I got the degree in 3 years, and I wanted to stay in undergraduate housing, so I didn't finish. Then I did my master's at MIT in mechanical engineering, and when I finished the master's, I took the PE class. I took Frisbee, and that gave me my undergraduate degree, and that was in '87. So I got both degrees in '87. And then the Ph.D. came in '97 from MIT in mechanical engineering.
Okay. So there was other stuff then in between.
There was some other
take
stuff
you 10 years to get your PhD. And so you mentioned going to Europe. That was before MIT, obviously. It was, right?
It was after high school, yeah.
After high school, before MIT. Okay, so... And I somewhere picked up that you paid your way as an itinerant juggler and magician. Can you just talk a little bit about that?
Well, I guess to jump back for 1 second, the motivation to go to Europe to begin with was because my high school girlfriend was an exchange student, and so I was following her to Germany. That was the initial motivation for the whole thing. And so I needed money quickly. It hadn't been part of a long-term plan. I needed the money quickly. I opened the I called it an office. It wasn't an office. It was just in my bedroom, an ad that brought in some people to do some work. Got the money and got on the plane. So once I was there, I eventually left Berlin and started hitchhiking around Europe and North Africa for a better part of a year. And in that time, to get extra money, I would use my juggling and magic skills in the street to get extra money. And it ended up being quite lucrative. It was a nice way, because you could just work for an hour or two and pay for the day of living.
I never tried something like that.
It's a great way to meet people. I ended up connecting with people. I spent a few weeks traveling with a circus, and I met them through juggling and magic.
Cool, really cool. Okay, so then what happened after you got your degree? So you came back from Europe, you went to MIT, you got your degree, and then
Graduated, applied to two places. I applied to Apple and I applied to Disney.
Disney?
Disneyland, as a Imagineer.
Ah,
And the pitch I made to them was that I have a background in magic and robotics, because that was my degree from MIT. Was both of them were in robotics, undergraduate and masters. At least I should say my thesis. I mean, the degree was in architecture and mechanical engineering, and so my professor at the time was studying construction automation. So I made a robot that built walls. That was the connection back to architecture. So that was the pitch to Disney, was that I have this background in robotics and magic and engineering, obviously, and so I would be great at designing rides at Euro Disney. That was my pitch. I wanted to go to Euro Disney. It was that was the time they were building Euro Disney, and the other was Apple. Those were the two places I wanted to be, and didn't get the job at Disney, but I got the job at Apple.
so what made you? Why did you want to go to Apple? It's so. It has nothing to do with architecture.
Why did I think it has to be just that I saw Apple as some place that was changing the world at the time. And
they were in '87, right? That, yes.
Yeah, my architecture, one of my graduate courses in design, it was energy conscious design, used the Macintosh. It was one of the first programs that used the Mac at the time, which is crazy. I mean, we were doing architectural drawings on a screen this big. It was insane. But it gave me a lot of exposure to the Mac, and I fell in love as a tool and thought it was an important place to be.
And so you went back to the West Coast.
Yep. Moved to Palo Alto and worked in Cupertino.
So before we get into the details, can you get just a rundown summary of the projects you worked on in order?
Well, I was very lucky in the job that I got. I think what happened is that my resume just bounced around from desk to desk, and by luck, the person who picked it up and took interest was a man named Andy Carter, and he was doing input devices. There was someone who was leaving, and that person was a senior engineer who was working on a small team doing the mechanical engineering support for this group that was doing high-end research on what the future of input devices could be. And so I was lucky enough to get dropped into basically his old job, which made me hit the ground running, because I wasn't hired as a newly minted engineer who had never done anything before. I was hired to fill the role of someone who was, I think his job description said 13 years of experience, or it was 8 or 13 years of experience, was actually what they were looking for. And so I remember on the first day, Andy Carter came in my office and said, okay, here's what you're supposed to be doing. And he gave me this list. And at the time, I was like, oh my God. And then he left and he said, I'll talk to you in a few weeks. And that was my introduction. But he gave me working on, it was codenamed Beehive. It was a stylus that allowed the user to write or draw, and simultaneously the computer would observe what they were writing and drawing in three-dimensional space. So it's not, the tablet was dumb. It was just, you could just write on any piece of paper. And there was a base unit that was tracking the pen in space, yaw, pitch, and roll to 0.2 millimeters and 0.2 degrees. And from that, the software people were determining where the tip of the pen was, and was allowing it to do handwriting recognition and drawings and et cetera that were automatically being absorbed by the computer. And my role was to design the pen, the ergonomics of the pen, and also to make the antennas. The antennas, well, I was working very closely with the analog engineer, who's Florent Oprescu, and the two of us were, designing how big the antennas had to be in terms of the area, and my job was to try and figure out how to get it all packaged into the space.
So it was wireless, not tethered?
It was tethered. In the first version, it was tethered. I mean, the whole technology was based on the Polhemus device, which is a building and collapsing a B field. It was an AC B field technology that was known. And we weren't innovating on the raw technology. What we were doing was taking a military grade device that was at the time it was used in cockpits, military cockpits, to identify where the pilot was looking for heads-up displays. We were adapting that technology to becoming a $150, cheap consumer item. So in order to do that, we were redesigning it from zero. And the other part of the role was to make a robot that had no metal in it, so that we could characterize the antennas. And it wasn't for production, but what the robot would do was it would hold the antenna in one location, it would move it this 0.2 degrees, we'd take another measurement, move it, take another measurement, and we're trying to characterize the entire, 2-meter sphere, because it's 1 meter on each side. So it would take hundreds of thousands of measurements over the course of weeks to characterize what these two antennas looked like, so that Florent could modify the antennas and do his part of the job. So we were working together in that aspect. So I had to draw, you'll see the picture, of a robot that had no metal. And the more you think about that problem, the harder it is, because any metal would mess up the magnetic field. So the only metal, there's no metal in the motors. The non-metallic motors was an interesting problem to solve. And so the only metal in the device was the wires. That was it. That was the compromise, was we couldn't communicate with the robot with no wires anywhere. But so for the motors themselves, I used these ceramic inch drive motors. So there'd be very small piezo ceramics within these discs, and what it would do is you'd pump in some voltage, it would expand the ceramic,
and it ratchet thing,
and you would do that thousands and thousands and thousands of times, and that would cause the motor to turn.
Now, just a question. In actual use, though, the user will have a wristwatch, a ring, whatever, so there'll be metal to mess up the field, to change the field. So
I can tell you it worked, and it didn't seem to have. I think when you're designing things, especially when we were designing things at Apple, there was everything was done to the highest level, and so we were trying to create perfectly spherical fields, or at least perfectly repeatable fields, so that we could map the variations and know in the perfect environment where it should be, and then knowing that in the real environment, there may be some small distortion, but will the person ever be aware of it? Probably not.
I guess the person gets the feedback. Right,
yeah, I can only tell you that having used the device, the software people came with some amazing applications. We had Micmac draw in 3D. So instead of drawing a square, you could use Beehive, and you would draw a cube. And then you could grab the cube and you rotate it, and you're watching this on the screen. Grab the cube and rotate it, and you could make another and make a Boolean and connect these, make a sphere and a cube and draw three-dimensional objects in space in this imaginary cube in front of you. And this was in 1988, 1989. And it was exciting.
Was the Stylus powered?
It had a little battery in it. I mean, that was the version the second version we were working on was battery powered, but at the time we only got it to tether before we stopped the full project. The final working one was tethered and did not have a battery.
Did it go into production?
No, many levels above me made the decision not to pursue it. I have no insight as to why. I think it was, I'm going to guess it was just market size. I think in 1989, the market for three-dimensional drawing, and it was small. And yet it was very cool that you could just draw, I mean, you could do handwriting recognition on any piece of paper as good as handwriting recognition was at that time, which wasn't very good. So I think these were the problems why we never brought it past the second revision of prototype.
Okay, so what came next?
The other thing that Andy asked me to work on in that first meeting was a fiber optic network. And it was the only thing, the fiber optic network was odd man out in that group because I was an input device engineer, was my title. And that was the focus, except for this one odd project, which I think he got because of his interest in high-speed communications. So we were working with AT&T, and the story, as it was told to me, was that AT&T had finished wiring the country, and they had all this capacity, and now they're just looking around trying to figure out what to do next. So they approached Apple and asked to put together a project, and there was an agreement to explore putting fiber optic onto desktops. And we got fairly far. We had functional 100 megabit desktop LAN, FDDI implemented LANs working. And
that is amazing. I worked at a startup in '92, and we had thick LAN with a thick coax, and the taps were a needle going through the shield into the sensor conductor, and you did fiber optic LAN. That's amazing.
I was my role was to design the ergonomics of the connectivity, because there was rules on, it was a star network, and there were rules on how you connect and how you cannot connect. And the idea was to make something that was completely intuitive so that the users wouldn't misconnect things. And so there's a visual language and a mechanical and visual language, and that was my role.
You want to hold it closer
Sure.
into the picture?
So this is the prototype, and the idea was that the pigtail would go into the computer. And when it was powered, there would be a mirror that would move out of the way so that the fiber optic signal would go into and be read by the FTDI module inside the computer. And when the computer was turned off, the mirror would fall back into place, and then the optics would bounce it back through the network. So you could have many, many computers in the system, and if some were active or inactive, the system would continue to work. And we had it all running. And I imagine it was the same issue. It's just there wasn't a large enough market. And there was actually a fun story, which is that one day my boss's boss came in, and the whole group sat down. The whole group wasn't very large. It was like 5 or 6 people. And he shook his head and he said, "You people are screwing up." And we were looking at it sideways, like, because we've been very successful. We had no idea what he's talking about. He said, you people are screwing up. You're my advanced technology group, and everything you do works. That means you're screwing up. By definition, if my advanced technology group is always succeeding, that means you're not pushing the envelope, and that's the reason I have you. So I expect failure from this group, and if I don't get it, you're out of here. And he was serious. He was, I mean, he realized how absurd it was, but on the other hand, we all saw his point, right? If everything we do works, then we're not pushing hard enough. And that was part of the reason. There was a lot of things to love about Apple at the time, and that was one of them. And another one, which I guess is leading into our next part of the conversation, is one of the things that Andy introduced me to was 20% time. And I think 20% time is not taken very seriously in a lot of companies, but it was taken seriously at Apple. And so the idea was that one day a week, at least 20% of your time, go do something that envisions what the world should be. And so I gave myself the project. At the time, mice and trackballs were all friction-based systems, and you'd have to take them apart and clean them often, and it was clearly bad. And I gave myself the assignment of fixing that problem. So I worked with, there was a guy named Greg Blonder. He was at AT&T, and he was a technologist, and we got along well. And I met Greg, and so I told him about this problem. And he said, well, what about the idea of using a magnet on the inside of a trackball and watching the field go around and using that as a non-contact method to detect trackball? That sounded good. So I was working on that project. So I guess part of what was fun about being at Apple at the time is that these projects were supported. I had funds. It wasn't infinite. Sort of felt like it was infinite. If I wanted to do something, I could do it. And so I had funding to work on this project with Greg. The other nice thing was that by being at Apple, if you asked a company to do something, they would often do it for no money, just on the hopes of having a project with Apple. The Apple name went very, very far. I assume it still does. But we were able to go to a company, happened a few times, and I would tell them my vision of what I want them to do, and they would get to work, and they would come back and they'd say, "What about this?" And it never actually worked that way. But so back to my assignment. So one of the things I gave myself to do was to solve a trackball, and I had this idea of touching a surface and having the cursor move. And it came out of magic, and the idea of you would decide what you want the world to be like. What is something that you'd like to present conceptually? And then work back to make it happen. And that would be a good trick if you're inventing a magic trick. And so I was at my computer and thought, well, it would be cool if you could just touch it and the cursor would move. And so I started working in that project, and I opened up a project with a company called Microtouch, which had FSRs. They were big at the time, which is a force-sensitive resistor. And you'd press on it, and they had mostly one-dimensional, but they also had some two-dimensional arrays. And so I was working with them to develop a touch-sensitive surface that you could embed into a computer. And another one of my roles, I forgot, another one of my roles was as the input device guy. People would invent things and give them to Apple to look at. Often new mice, new ways of communicating with the computer, man-machine interface. And I became the guy in the company, and they would all feed to the input device group. And since I was the mechanical engineering person in the input device group, they came onto my desk. And So my job was to look at these things and say whether they're good or not. And if they were good, I would work with the inventor and try to develop it further. And if not, send a nice letter and say we're not interested. And I probably looked at, I don't know how, many different inventions, and they were all bad. Were all bad.
Like what? I mean,
Well, one of them, the one that I remember the best was a gentleman came in and he had a touch surface, which excited me. That was my pet project, was touch surfaces. He had one, and he sat down and he set up his demo as a big thing, and he set up and he put his hand on it, and he was controlling the cursor. I was impressive. Like, okay, let me try. So I try it, and the cursor going zing, zing, zing. It's all over the place, completely out of control. And he's like, no, like this. And sure enough, he could do it. He could do it. I don't know how many hours he had practiced with this thing, but he could make it work. I could not even come close. I considered myself a fairly coordinated guy, couldn't make it work. And so he didn't rise to the top of the pile. But there were a few touch devices that came through. None of them were of interest. And I tried to remember how I got to George, a Graphite Proxima, the touchpad we ended up using. And I honestly couldn't remember whether I reached out and found him or whether he had sent something inbound to Apple. But should I just talk about George, or do you have a specific?
Sure. First, before we get to him, maybe on the trackball, you did mention that you greatly improved its reliability.
That comes much later.
Okay. Then sure, go ahead with the touch.
Yeah. So my memory of George is that he came in and he gave a demo, and it was not like this guy, where it wasn't great, but it wasn't bad. And it worked. And was very impressed. He went away. I talked to Andy and got Andy interested in my project, because at the time it was just me. There was no one else was working on this idea of doing a touch device.
Okay, so Apple did not.
Apple had no interest. It was not an Apple
touch it.
project.
Okay,
No, this was my 20% time.
Okay.
So George came back. Oh, and it was the story of George coming back was he didn't have the money to return. And Apple at the time was going through these quarters where we're not allowed to spend money. An edict would come down from Scully. No cash is going out, until the end of the quarter. And it was for the balance sheet, right? They were trying to make a nice, pretty balance sheet. And George wanted Apple to pay for this ticket. I was like, so I just wrote him a check. I just wrote a personal check to George and said, here's the money to take a plane and come here. And so George came back, and I showed my boss and got enough interest that it became a real project, because now I wanted to spend money. And like I said, it wasn't great. So we worked on making it better. And I don't remember the specifics, but I remember giving him a list of things that I wanted improved. It was more stability. There was some jitter, and I wanted those things addressed. And I think some acceleration. I wanted to change acceleration curves because they weren't what I wanted to see. So sent him away, and we're paying him for that work. And he came back, and he hit it out of the park. It was what we wanted to see, and worked with my team, Andy, and we put a deal together with George. It's a long time. I probably can say what it is at this point, but at the time it was top secret. But we put a 3-year exclusive, and we paid him one time for all rights. So Apple would never, past that check, we paid him for exclusivity and all royalties for all time. But that $1 ended up being, I think, what set George on his path to great success. And
So, what was your intended use of the touchpad?
well, at the
A
time,
separate thing,
we were
keyboard
still.
adjunct?
I was still in research at that point. There wasn't. I had no connection to a product.
Okay, so you were just researching into devices.
Yeah, there was no connection to a product at that time. It wasn't slated to be part of anything.
But you paid, Apple
gave him
paid
$1
him money. So
million bucks, yeah, but we gave him that because we knew we wanted the technology. But it was still living within, it was in a research group, not a product group.
What year was it when you paid that? When Apple?
I was still with Andy, so it must have been the first 2 years I was at Apple. So I'm going to say 1991. And so now I guess we're migrating to your question, what am I going to do with this thing? And so I had this technology and I started looking at the question of how will this be integrated into a product? And I made myself a want list. I said I want it to, at the time, the portable had a trackball that you would swap. So left-handed people would put the trackball over here and move the keyboard over here, and right-handed people would put it over here. And I didn't like that. I didn't want it to be dexterous. I wanted it to be ambidextrous. So that was one of the things on my list. And then I explored in many different possibilities of how you would get a device to the front center of a laptop. And there was swinging out, it was sliding from under the keyboard, there was integrated with the keyboard. There was one design where it was just underneath the keyboard itself. So there was no separate device. It was just...
You would slide the keyboard?
No, you would slide the keyboard. There was George's technology it actually works at a distance. He's tuned it so you think that it's a touch, but it's not. It's capacitive and looking into the air. So, obvious question, well, not obvious question, but a question for George was, how high can you look? Can you look all the way through a keyboard so that the person will be touching the actual surface of the keys and believe that that's the device, that's how to move the cursor? And the answer was not reliably, especially the keyboards were a little thicker then.
And it would be a very large device too.
Yeah, potentially what it would do, well, his device is a PCB. So the concept at the time was that you would make the keyboard PCB have tracks in it that were the contact PCB. So the same printed circuit board would simultaneously provide the touch device and the keyboard device. Which was a mouse patent I filed on, which was an interesting thing that I should go back to. But so I looked at all these different ideas, and the one that I decided, I didn't like mechanical swinging. There was slides and things like that. I rejected all of those. I wanted something that was fixed, and so I came up with the idea of putting it in the front of the keyboard, which was rejected. Everyone who saw it thought it looked very weird. But so this was the first implementation of that. And I believe this is George's touchpad. And this is a device that I made so you could slide under a desktop to give a demo. You just slide in the desktop, and I took a magic marker and I just drew a line around the keyboard on this extended keyboard and said, well, that would be the laptop. Sort of waving my hands. It was very early in the process. So I was just explaining to people, see now if you're on an airplane, because we had the portable at the time, and you sort of, on an airplane, you'd be typing like this. I said, it's nice because you have these palm rests, and now you have more room. It makes more sense. You can push the computer to the back of the palm rest of the seat in front of you.
Okay.
Well, sorry about that.
Everybody thought it looked wrong, but in an airplane,
Yeah.
it would be handy to have a palm rest.
So I wanted to, let's see, how do I jump back in? When I first made this device, in order to slide underneath a desktop keyboard, I would take a magic marker and I put a line around it and said, that's what a laptop computer would be. And I explained what I saw as the benefits. Because people, when they saw it, they thought it just looked very strange to have this enormous space in front of a keyboard. And so one of the benefits I said was that if you're on an airplane, instead of typing like this, which is the way the Apple Portable was at the time, you can spread out, and then the hinge would be at the back, and it seemed to be a much more ergonomic way to use a laptop computer on an airplane. And at the time, airplane use was, these are very high-end devices, and airplanes seemed to be the most common scenario, at least for marketing purposes. That's what people were talking about. And I also mentioned that instead of it falling off your lap, because helps to hold it. You're actually holding the device onto your lap. And so I had these various ways to explain why anyone would want such a weird-looking thing. But really, I was trying to create a space to put my trackpad, which I was pitching. And I ended up showing it to people up and down the chain. And at some point, people from the Portable group came over into the research area. And I showed Roger Momey and Medica and John Krakauer this, and pitched them on the idea of having this be in laptops. And they liked the ergonomics of having the palm rest, and they liked the trackpad, and that's when I moved from research into product.
So was the idea of a laptop already floating around Apple?
Oh, absolutely. I mean,
with a hinged screen?
Yeah. Other companies already introduced laptops at that point. Yeah, Apple was late to the game. Toshiba had one, and Compaq had one, and all of these, they were plug-in mice, and yeah, there was one of them that you would attach a trackball to the side, and or you could plug in a mouse and have it separately. I mean, that was what everyone was doing at the time. No one had anything like this. And so I moved over from research into product. At the time, the laptop group didn't yet exist. So I was the third member of the laptop group. It was this big empty area. I was sitting over there.
I don't remember an Apple Portable. That was
sort
of like the Osborne at the time, or
it was a luggable. No one called it. We called it that. I mean, it was the Apple Portable, but I remember that there was a woman who worked at the front desk, and at one point she picked up Apple's Portable and had to file for medical injury. She was out. It weighed 16 pounds, and she got injured lifting the Portable. It was not a great computer. It was very big. It had huge batteries. I don't know how many of them they sold. It was not a great success. And at the time, I think it's worth noting historically, at the time, Apple was not doing well. This was a period where the printers were what was keeping the company afloat. But for printers, the company would have gone out of business. And Apple needed something else. And the laptop was seen as that thing that would save the company. And so I moved to that group, and the one thing I was going to mention was this other idea, which I got a patent on at Apple, but they never did it. And I still think it's a good idea, which is to have you put a transistor in a mouse, and then you can tilt it and use that as input. So you could use 4 if you just wanted north, south, east, west, or you could use 8 if you wanted to do all points on the compass. And the idea was that when you picked up the mouse into any one of those orientations, it would be a function. You could use it as delete, or you could set it. It'd be the equivalent of all the functions that you could select.
Because it only had one button at Apple.
Yeah, Apple had one button, which I always found a little annoying. I think one isn't enough.
That was one thing I meant to ask you. What is your opinion about a one-button mouse? Whether three buttons plus a scroll wheel, whatever.
I have pretty strong opinions. First of all, I think mice are horrible. I don't like mice. As someone who's had carpal tunnel problems, I think this action of having that long cantilever, from a purely mechanical standpoint, having that long lever arm and putting a force, so it's a high force, is hard. And using the thumb just makes more sense in order to actuate a button. And using this part is much better. Your fingers aren't involved. So I'm a strong advocate of trackballs. But in terms of number of buttons, I think there's such a thing as being too simple. And many buttons, that's bad too. But I think a 2-button mouse is probably the right number of buttons for a mouse. And a scroll wheel, I love scroll wheels. I think they're great. Yeah, I was disappointed they never did the tilting thing. So I moved to product in, I'm going to say late 90, 91. It was the 2-year mark. It was at the end of 2 years of me being at Apple. I moved to the product group, and it was completely different. Instead of being in a small 5-person group of specialists and a lot of camaraderie, the product group felt much more cutthroat. There's tremendous pressure, you can imagine. Right? You have a date, and you got to meet that date. And someone, by definition, somebody on the team, the display guy, the battery guy, the plastics, the input device, someone is behind. And whoever that person is in the meetings, we have these big meetings, 20 people around a desk, and someone gets a lot of flack thrown at them because that person is risking missing ship date. And you never want to be that person. You just never want to be that person. So there's pressure. But my role I was the trackball person on Duo. So it was the first product I had designed from a blank piece of paper for production. And I made significant amount of innovations to get, this is it. This is the Duo trackball. This is a prototype version of a Duo trackball.
Remind me what Duo means.
Duo, the marketing guy came up with Duo. I had never really had an appreciation for marketing at all. I thought it was soft sciences. It was just hokey. Until I met this marketing guy at Apple and watched him work and saw his bridging the gap between what the public wants and what the engineering could provide in a very meaningful way. And he did brilliant. So Duo, to answer your question, Duo was simultaneously a desktop and it was a laptop. It served both functions. It had a base unit, and you would snap the laptop into the base, and it would immediately make all the connections and talk to the screen, and that's what that was doing. So, but it was very, very thin, and we still didn't have the touchpad working. That's a longer term project. So that, it grew from being just me. For the first year, it was just me. And me and George, or first it was me, then me and George. And eventually it became a whole project. But that project had not finished. The two didn't match up. So Apple ended up shipping several of its early laptops with trackballs. And they would continually get smaller. So the Luggable had an enormous trackball in it. And then the 100 had a smaller version, and this was pushing the edge. So in order to make this, one thing I did was because by making the ball so small, it started to feel cheap. And it was still friction-based, so you wanted weight to make sure that the springs were getting good contact. Because if you push harder on the ball to ensure better contact, you also just pop a light ball right out of the housing. So my solution was to throw a hunk of steel on the inside of the ball. That was the first thing. So to weight it down and give it a sense of quality. So we overmolded a ball bearing. Then I went to ruby bearings, because the old trackballs were using these needle bearings that were like $3 a piece, even in quantity. Extremely expensive. And I replaced them with rubies, artificial ruby, that brought the price down to 45 cents for the whole set from $6. So that was huge innovation. And then I did a bunch of research and realized that if I put a ridge on the center of the friction wheel, it would become self-cleaning. As instead of dirt just building up on a flat surface, the dirt would be washed away by the pressure of the wheel hitting the ball. So the dirt would be pushed off into the area next to the ridge instead of sitting on a surface between the ball and the roller. And it worked well in my little laboratory, but then I made some, and we tested them, and there was a fun story there because we had the testing group, and Apple had a very rigorous. Apple was very quality focused and still is today. But one of the tests we would do, there was a Doritos test on trackballs, and there was a distance test. And I think the Doritos test happened after the distance test also. So the Doritos test was just what it sounds like. You sit around and you think, what's a realistic test? Well, people eat salty foods. What about eating some Doritos and then seeing if the trackball still works? That's a good test. So that was part of the Apple spec. You would eat some Doritos, you'd play with the trackball, and it had to actually work. And then the distance test, I forget it was 50 kilometers or 100. But there was an XY plotter, and you would take your device and you would put it onto the plotter, and it would randomly do this for days. And it would take a accumulated distance, and it would measure when you got to 50 kilometers, and then you'd repeat the tests to see how much wear there was and to see if it still worked after. There was some correlation of how many years of use correlated with 50 kilometers. And
so it could check during the test for skipping? Or
You could. Oh yeah, what it was doing, it was plugged in. So during the entire test, you was measuring whether it was still working, if you had missed data throughout the test. But then you take it off, and you would repeat the Doritos test off the machine. And there were other tests too. I think there was a hand cream test where you would put hand cream on your lotion, just hand lotion, and then you'd let it dry for a minute, but then you'd still have this greasy, and you'd repeat the test. So with this, I gave it to the test group, and they ran the standard 50-kilometer test that they do for all devices, and they took it off, and they said, "You cheated." They accused me of sneaking in to the lab and replacing the test units with brand new units at the end of the test. I was like, no, I did not cheat. It never even crossed my mind. And because it was perfect. The reason they accused me of cheating was because they'd seen, they've done many trackballs at that point, and all of them had degradation. This one did not degrade. It was still perfect. And so they repeated the test. I don't know whether they used the exact same ones that had already been used, run 50 kilometers or not, but they repeated it for another 50 kilometers. And this time they locked the room, so I couldn't get in. And of course it was the same, because it's a good device. And so I was very, very pleased with that. And I believe that the actual long-term spec said 100 kilometers, which is the first one. Remember, it was double the normal. I think they were just trying to, they could, so they did. So that was my first production unit. Felt very good. Oh, the other innovation on this was that it was sealed. So if you look at other trackballs, you can see the guts, right? You look inside and you can see electronics, you can see the wheels, you can see a lot of stuff. And in the Duo, I made, instead of making a cup this direction, I inverted the design so that it sealed on the outside and there's nothing visible. I think that was, I don't know if that was the first time that's happened. It was a small thing. It was the least important of the innovations that was part of Duo trackball.
So when did Apple then sell built the first laptop with a touchpad in it?
It may have been after I left. I think it was the 500. I was at Apple, I shipped the 100, 140, 170, 210, and 230. Those 5 units. So I was not there for the shipping I ended up leaving before then. There is a good story on the 100. To give some context, at the time, there was a lot of talk about the Japanese miracle. Japan was coming up with a lot of innovation quickly, and there was a discussion of how they were doing it. And we were Apple, and we were curious about the Japanese miracle tool, and so the executives had an idea for how to get the answer. And we had this large 16-pound portable, and one of the projects, we thought the fastest way to get a laptop to market was to repackage it and just take that same electronics into a new box and ship it. And they thought that was a perfect project to give to the Japanese. So Apple approached Sony and said, please do this project for us. And they paid them, I think it was $20 million to do the project, maybe even less. It was 10, I think it was 10 or 20. And they did, and we saw how the miracle worked, and it was cool. It was a large cubicle next to mine, and it was staffed with 4 or 6 Japanese engineers.
Oh, they came to Cupertino.
They came to Cupertino, and they worked 12 hours a day. And then they stopped working, and they went to sleep, and the team in Japan started working. And that's how they did it. That was it. It was a 24-hour design cycle. They never stopped. And so they designed the Powerbook 100. And the problem was we got near the ship date, and the trackball was bad. They had miniaturized what we had, and it was sticky and wasn't usable. We couldn't ship it. That's when I got pulled in. I had got some reputation at that point, as a trackball guy and an engineer who could solve problems. And so my boss pulled me off of, I guess he didn't pull me off anything. He just said, can you help us? And so I did this charrette quick design project to figure out what was wrong and implement a solution. And so I called up the compounding company and had them make an array of 1090s, 2070s, and with 3 components of different plastic ratios as plates. We didn't have time to make balls. They just made me plates. And then I had these plates, and I took the rubies and I made little jigs, and I had a tilt table, and I just waited till they slid, and I figured out which of the compounds had the lowest friction, and I decided, had an ISOD number that was high enough that it wouldn't wear too quickly. And I made a call, and I picked a ratio, and that was going to be the new plastic design for that trackball. But then we're getting closer.
For the ball?
For the ball.
For the ball.
Just designing the ball. The plastic of the actual ball that's going to go in the trackball. And we're getting closer and closer to ship date. And it became clear the only way that we're going to meet ship is if I do this gymnastic thing with my area associate. So I approached this woman, her name was Susan, said, Susan, you want to go on a trip? She said, sure. So we gave her 2 empty suitcases, and she flew to Colorado, and they filled her suitcases with as much plastic, raw plastic, as they could. And she got on a plane with raw plastic. And the concern was that if we tried to use shipping companies, that it would get stuck in customs, and we didn't have that time. That was that close. We had to have a person hand walk it through the entire process. So Susan got empty suitcases to Colorado, raw plastic, and flew to Belgium. Belgium was where they made all the balls. Belgium has been the world's premier source for perfectly round balls for centuries because of billiard balls. They make billiard balls. And so we used Belgium manufacturers to make our trackballs. And so she flew to Belgium. Manufacturer made every trackball they could possibly make out of her 2 suitcases of raw plastic. They gave her a bag full of balls, and then she flew to Tokyo. And she gets to Tokyo, and she does a handoff. Here are the balls, and they swapped out the bad ones, and they put in these new ones, and they shipped the product. And that's how we met the ship date. And that was a tense time, but it was fun because I didn't cause the problem, and I was just the hero for having stepped in and solved it. But I'm sure if I had been the source of the problem, it would have been terrible.
Wow.
Anyway, so that's the 100. That was the very first. It was the first laptop, and I guess it was the validation. We sort of jumped over all the work that went into proving that this concept was acceptable. It was over the top. I don't even remember how many user tests we did. Many user tests. We would finish a user test and we'd give the data to senior execs and say, people like it. And they didn't believe it. It was too much of a risk. I mean, we were betting the company on the laptop. And it looked weird. Back in 89, 90, putting a palm rest in front of a keyboard looked strange. And the execs did not want, the worst possible thing you could imagine at Apple is to introduce something and have it become a laughingstock, right? As a weird looking thing. And so they would finish the user test and it had good results and they said, do it again. And we would do it again, and it had the same good results. And they'd say, do it again. And we did it so many times, I ended up I soft-tooled devices, because we were making so many of them for testing. And that's what this is. And then here was an earlier one of the earlier user tests. I think this is for the Duo, because this is that small trackball size. This was me kludging up. This is a prototype trackball. I used this is prior to the Duo trackball actually existing. So I made a small ball work in a format using the old electronics just as a prototype. But at the end, after all this multiple rounds of testing, they finally said, it's a go. And the 100 was the time when the rubber hit the road, and we found out the public actually likes it. And I remember being on a plane. I don't know where I was going, but I was on a plane, and I saw a guy across the aisle with a laptop. And at the time, we had been in development for a long time, and they were floating all over the building, people with laptops using them inside the building. And I think I had seen someone with a laptop outside, but he was an Apple employee, so it didn't matter. So I leaned across the aisle, and I asked him, are you an Apple employee? Because an Apple employee, I couldn't care less. So what? But he said, no, I'm not an Apple employee. And I started to cry. I did. I got teary. And this man, because I was watching what he was doing. He's using, he's using his thumb, and he's going, all the things that I'd done in user testing, and the positioning of the button and all that stuff I had worked on so much. And the idea that some guy was using it in his daily life, and my effort had gone into the world and was now changing this man's life, that was powerful. That was the first time. That was the first time that had ever happened to me, and it was a lot.
Wow. So, I guess that's all that you worked on at Apple that we have covered? The network, trackball, touchpad?
Yeah, no, in R&D
Powerbook.
We did the Beehive, Dark Crystal. There may have been little projects, but and then I just became the input device guy in the portable, or the laptop group. And then I left the company.
Wow. Why?
Well, I had done some pretty important things, I thought. It was exciting. It was incredibly exciting. And I felt like I hadn't been given a lot of recognition. There was a struggle over who was the inventor of the palm rest. Everyone in my group knew that I had done it, but there was someone in another group who had done a piece of paper mock-up, and that doesn't count as a reduction to practice. I mean, legally, that's not an invention. There's no difference in writing it on a notebook. This was the first reduction to practice. In any legal sense, this is the first one ever. And I was the inventor of it. And so there was a little bit of animosity that I hadn't gotten as much credit as I thought. He was a higher person, and I couldn't fight him at the time. I was still a young engineer. And I think it was largely political that he was given credit. So there was a sore spot there. And also, having done these important things, the company then wanted, understandably, it's not a ding about Apple, but going forward, we were just going to make smaller versions of the thing I'd already done. We were going to make it a little thinner, we were going to make it, a little bit smaller, lighter, it wasn't that exciting. So for those two reasons, I decided I was done. That was enough Apple.
Did you regret having left the R&D group?
No. I mean, yes. I mean, the minute I said no, it reminded me how much I miss it. The answer is you can't do everything, and I learned so much from being in product. I mean, Apple, to this day, I will say only good things about Apple's product development process. They nailed it. One good story is when I went back to MIT, I just got there, and I went to some lecture on something, and this guy was talking about next generation manufacturing, and he was talking about just in time, and he was giving a lot of process manufacturing details, and I was confused. Apple was already doing all the stuff he was explaining as what his vision of next generation manufacturing. It's all history. And so I learned a tremendous amount from being an engineer at Apple. One of the things that we lived and breathed at the time was the edict of no compromise. So you'd be sitting around a table, design meeting, having a discussion about what we should do, and an issue would come up. And we'd start banning and debating on what we should do, and somebody around the room would say the words, no compromise. And that was the direction. We now had a direction. And everyone knew how those two words fit into the context of what we were discussing. And suddenly, we knew what the answer was. And that's where we head. And it was, I'm not sure it works in all circumstances, but if you're in a company where infinite resources and we didn't need to compromise, I think
that is a rare place.
It is a rare place.
For me, engineering is about compromises.
It was a great learning ground. I mean, what I learned after leaving Apple is compromise. I mean, one of the, what do they say? Is like anyone can make a bridge stand. Only an engineer can make a bridge barely stand. Right? That's what engineering is, right? Engineering is the art of making it work properly, making it designed to a task, not just do it. And to some extent, Apple at the time was really just about making things as good as they can possibly cost. I mean, we were using $3 bearings. It was crazy. Cost was not. I mean, Apple was famous for being expensive at the time, and that got fixed. But that's where we were at the time, and we also had parties that suited. And there's our Christmas. I would say my division, right? R&D division. Christmas party. The entertainment was Cirque du Soleil. I mean, that level of extravagance. I mean, they flew in a Cirque du Soleil for my group of 100 people. I mean, it's crazy. That's what it was at the time. I mean, stretched limousines to and from the airport for just me.
No compromise.
No compromise. Yeah, it was as a 25-year-old engineer, it was a lot of fun to live that, to have that experience. It was great. From intellectually and the great people, most of them. That was the other reason why I left, was that my immediate manager at the time and in product group was one of the worst ever. Yeah. So that was another reason I had a bad taste in my mouth from that.
Okay, so then you went back to MIT right away?
Yeah, right away. So I had applied to Berkeley, MIT, and Stanford, and chose MIT again. It was just Stanford wasn't going to be supportive of what I wanted to do for my Ph.D. They didn't think there was such a thing as design Ph.D. Okay. I wanted to do ergonomics. I wanted to take ergonomics and make it a science. That was what I wanted to do at the time. And Berkeley wanted me to sort of earn my keep. You have to do things to get support, and at MIT I could do anything I wanted and get paid and not have to fight. And so it's path of least resistance just to go back. And so I think it was just a few weeks after leaving Apple, I was starting my new semester as a student again, which was a little hard at the time. I mean, it's not being a student for a while was very different.
Yeah, you were at Apple 5 years, right? So.
Yeah. I mean, I strongly advocate the idea of being in the real world to give school more context. I think it's fantastic. Might be a great general purpose thing to do, because it gave me a lot of context. Like going to this one lecture, as an example. I wouldn't have known. I would have just thought this guy had great ideas about the future of manufacturing can be. Having been at Apple, I knew what manufacturing was, and I think having your foot in industry and academia is a great mix.
I think I agree. Although I went to industry after academia. Well, I did few months of work. Anyway, so what was your PhD research about then, or your thesis about?
It changed. It started off in the belief that I could make ergonomics a science. I had developed a lot of theories about ergonomics. I became the ergonomics guy at Apple. And I looked at that for, 6 months or so, and I changed to a new project which I called the Urban Design Core. Because at this point, you sort of skipped over all the inventive stuff. I had been doing a lot of different invention activities.
At Apple?
At Apple. Seeing myself more and more as an inventor. And so I think I had even filed a few patents at that point. And I thought that invention could be a path to increase jobs in the urban environment, create jobs. Because I guess it went back to, I've thought about this in a long time, but it went back to the idea that every person I've ever met says, oh yeah, I had an invention once, I thought of something. And I thought, well, if everyone has inventions, maybe a few of them are good enough to make into products. And it would be a great story if you can go into a poor urban community, find an idea, take that idea, give them the legal support and the engineering support necessary to take that idea from concept to a product, and then have that product get built within the community, providing jobs. So what you would do is that was the idea for the PhD. It was create a system, a repeatable system to find inventors and their inventions, develop them, build them, and create jobs and economy in a system. I was like, wow. So I was talking to churches and homeless communities, and I was working to find poor inventors. And I probably worked on that for a year or two. And it's still a very exciting project, and I believe that given a decade, you could probably make it work. But my mentor, I talked to him about it, and he said, if you're not going to be in academia, you have to make a decision, David. If you're going to be in academia, that's a fine project. It's a great project. If you're not going to be in academia, you're going to go back into industry, it's a horrible project. It's going to take you a decade. If you're going to go back into the real world, you need to finish your Ph.D. as fast as you possibly can, because it's just an obstacle to getting back in the real world. And I realized number one, my path was not to be an academician. I wanted to get back into industry, and therefore I needed a fast Ph.D. So I dumped the urban design core, and I changed to do the fastest thing I could possibly think of, which was a keypad that I had patented, which allowed a complete alphanumeric interface to fit into a very, very small space, like half of a credit card, half of a playing card. And
you had patented it.
I had patented
the beginning of MIT, or?
Yeah, I'm thinking the beginning of MIT. And it was the only, because I had done lots and lots of invention. Throughout, while I was at Apple, I started to do this invention idea, and I would stay in bed Saturday mornings, and I wouldn't get out of bed until I had something that I considered to be a good enough invention to justify getting out of bed. And I would just lie there, and eventually I would get excited about some idea, and I would just go through different spheres of life and find problems and think of solutions to those problems. And when I got something that was exciting, that I thought was manufacturable, it had all the price point, interest, solved the problem, it met all the criteria that one would want to have, I would get out of bed and I'd start doing patent searching, and that was how I spent Saturdays. So I had this idea of invention as a concept. At that point, I made this theoretical invention for the first time ever, which was the observation that electronic devices are continually getting smaller and smaller and smaller and smaller and smaller. And they're continually getting more complicated and more complicated and more complicated. So you have a line like this, and you got a line like this. And I said, well, at some point in the future, those two lines will cross, and there's going to be a lot of complexity in a tiny, tiny package, and the human interface breaks. So given nothing but that, in 90-ish, I started thinking about that problem. And at some point, I filed a patent on what I thought was an interesting solution to that, and it was defined in my own mind as had to be completely ergonomic, so a large man could use his thumbs to communicate with this keyboard. That was one criteria. And the other one had to be completely intuitive, no chording. There's a lot of chording solutions, like a piano. You'd use multiple fingers at the same time, but you have to learn how to do that. That's a non-solution. So it had to be intuitive, completely ergonomic, physically and mentally. And I came up with this idea for having hills and valleys in I call it passive chording. So individual keys, when you pressed in the center of keys, the separate keys electronically would be read as one key. So opposing two keys in an opposing diagonal, if you press them at the same time, the system would say, oh, I know what he means. He means the thing in the middle of those two. That would be a new thing. And by doing that, I increased the density by over a factor of 3, which is a big advantage, and no compromise on mental or physical ergonomics. So I just filed that patent away because there was no need for it. We hadn't crossed that threshold yet. I ended up calling it the ergonomic threshold in my thesis. I said that there will one day be a point where you will cross this ergonomic threshold, and when you cross that threshold, the world will need something like this. And I just sat on it, waited. And at some point, I was on a trip with a friend of mine, Shuguang Zhang, and we were about to go. I was in Japan. I saw these cell phone things being used in large quantity, and people were texting. They didn't have this in the United States. There was people, there were cell phones, obviously, but they were larger, and people used them for phone calls, not for texting. There was no mobile web. It predates all of that. But in Japan, texting was a thing. And I saw the future, and I canceled the rest of the trip with Shuguang. And we were at the counter, about to go to China, at the counter at the airport. We were in Japan, and I'm fidgety. I'm like, and the idea of going to China and spending a few weeks just traveling around, having a grand old time while the rest of the world was moving forward and leaving me behind, and it was too much. And so I just told them I can't do it. And I got on the plane, and I flew home on a ticket from Tokyo, from Narita, back to Boston, and I founded my company and spent the next 10 years doing that. And ended up calling it FastTap. We raised $22 million, and this was one of the early prototypes. That was a prototype of what it could be. This is just a mock-up. And then that ended up being products like this, and we would ship. That was an Alto. It was an LG phone. It's a full alphanumeric keyboard, and this one was for Cellus. And
so where are the number keys on it?
Number keys are exactly the same. It's so 1, 2, 3, 4, 5. It's the exact same 12-button keyboard as you're used to.
Okay.
But the letters are interspersed between the numbers. So if you want to B, you hit the B. If you
Okay, so the big keys are the numbers?
The raised black. The raised black is the letters. So it's A, B, C, D, 1, 2, 3. And I can use my thumb as easily as my finger. Even though it looks small, but surprisingly, a large man can just tap away and you don't get errors. So it's a zero error rate. I guess that was one of the criteria, is a zero error rate. So it is a zero error rate device. And it was, meaningless today, but at the time, everyone was triple tapping. If you want the F, you had to hit the 5 key over, until you'd cycle through. It was a nightmare. And so our business model was, by doing this, it opens up using text on the phone and using the mobile web on the phone to people that would otherwise just get dissuaded from the input method, which was the barrier. That was the barrier. And we ended up having, so after launch, we found out, that was our story. We kept telling this, but without data, it was just a story. So we ended up launching it with TELUS in Canada, and we found out that the ROI, we were charging $3 or $3.50. Doesn't matter. But our ROI was just over 3 weeks, which is insane. It's unheard of. And because the amount that the telecoms were charging for text and data at the time was quite high. And people were now using their phones to a much greater extent because it was easier to input text. So our business model was fantastic. We had a payback of under a month, and people loved it. Their data usage went through the roof. And we were flogging this thing like crazy, and we would have been a fantastic success, but for this device, this device came out and put a damper onto the future outlook of flip phones. And that was pretty much, that killed the company. And luckily, there's a good bad story, but the good part was that I had invented the idea of moving your finger over a touch surface on a QWERTY keyboard. So a QWERTY keyboard printed onto a touch surface, and you would just drag your finger around over the letters that you wanted. So to type the word truck, you would just drag your finger over TRUCK, and that shape, by looking at the capacitive, the touchpad looking at that shape was the word.
Oh, so without tapping.
So you would not have to tap, 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 tap. You would just do this. And so I filed a patent on that, and then it ended up, there was 3 different people who thought of that idea. But luckily, I was the first one. And so we ended up selling my company, which is Digit Wireless, ended up being sold largely for the value of that patent to Nuance in 2010 or so.
So I have one flashback question. I read that after you got your Ph.D., you taught at MIT, you stayed on a bit and taught a course about minesweeping.
Yeah, we were doing some achronology here, but when I finished the PhD, there was a program that had been funded by DoD to address the problem of humanitarian mines, humanitarian demining.
What do you call humanitarian?
So demining, landmines.
As opposed to a military campaign.
Exactly. So landmines.
Soldiers through.
There's hundreds of millions of landmines around the world, and there's 2 categories to address the problem. One is military, and one is humanitarian, and they have the opposite goals. Military demining, you got to do it fast, and it doesn't have to be so perfect. No, you're in a war, you're fighting, and you can't take a lot of time to make sure you're being careful.
That hadn't occurred to me.
So they're fast, and you can have casualties. At the opposite end of the spectrum is humanitarian demining, where you have a community, there's no more war anymore, but there's all these landmines lying around. People can't use a field for planting crops or even living. They avoid it, and you want to clear it out. And time doesn't matter. You can take as long as you want, but when you're done, it has to be perfect. Because if it's not perfect, they're not going to use that area anymore. It'll maintain as a question mark, and they're just going to go around it. So the military, I guess out of a sense of responsibility for having created some of these places, was wanting to fund research on humanitarian demining. And they'd given some MIT money, and the question was, which professor at MIT is going to teach the class? No one wants to do it, because none have specialties in humanitarian demining. How are they going to teach a class in it? Someone says, why don't you give it to Levy? See if he wants to do it. So I was approached and said, got some money, got a class here, you want to teach it? And I said, well, how about if I teach it as an invention class? Teach a class on invention, and the category that we're inventing in is solving this problem. How about that? They said, fine. Whatever. So I had some rules. I said I wanted to be able to pick my students, and I want a small class. I haven't taught before. A little class, I pick my students.
This would be a graduate level
level class. And they said, sure. And there was a bunch of money from the DoD. And I decided that it would be important to really learn about the problem at a fundamental level. And the best way to learn about the problem would be to go to a minefield and get trained by the deminers how to do this. You see the environment, you find out what they're actually putting up with. There's so many factors that you get from going into a real world environment, and instead of reading books or, So we had enough money to bring the class to Cambodia. And so I plastered posters around MIT, new class, invention, humanitarian demining, free trip to Cambodia, who wants it? Whole bunch of people show up. 40 people come up to the first day of it. It wasn't the first day of class. It was announced as a prerequisite to show up at this day. So 40 people show up. I give them my pitch, and tell them they all have to write a little short essay explaining to me who you are, why you want to be in the class, and I'll read through them and I'll pick. So I get all these resumes and essays, and I pick it was 6 or 8 people. And I picked them based on diversity. I had a nuclear engineer, mechanical engineer, electrical engineer, physicist, political scientist, forgetting one. But I liked the idea of having this hit squad, it was like a fantastic four of people with different skill sets to go solve this problem. So they were all graduate students. They all knew what they were doing. And so we're gearing up. And one fun thing about the class was that despite the fact that a lot of programs at MIT over the years have been going off and doing weird things, they've never required the parents of graduate students to sign waivers until my class. So MIT found out that we're going to a minefield in Cambodia. Right. And they said, we don't care that these are adults. We don't care that these are graduate students. You're going to need, no one's going on this trip until they got a waiver from the parents. And we got waivers, and we got them signed. And one woman was having problems getting her parents to sign it. And I don't remember whether she ultimately was allowed in or not. But so we're getting ready to go to Cambodia, and I'm working with this group on the ground there, and they call me up one day and say, it's been quiet. The fighting here has been quiet for a long time, but they're starting to do some active fighting. And it's not a problem, though. We will meet you at the airport with an armed escort for your whole trip. So we'll have armed escort, no problem.
And you have your waivers.
I have my waivers, but that was too much. I have a sense of adventure, but the idea of having class with armed escort was not on my list. And I thanked them very much, and we did not go to Cambodia. So instead, I called up Fort Belvoir and set up to get trained in demining at Fort Belvoir. So the class, instead of flying to Cambodia, the class flew to Virginia. And we spent a few days, and we got certified. So the whole class has a certificate. If I need a job, I can go do humanitarian demining in the jungle someplace with a authorization from the U.S. government. So we got this training in how to perform demining and they blew stuff up real good for us. They gave some demos. They had an anti-tank mine they set off so we could watch that, and it's a big explosion. And so it was fun. It was a lot of fun. And another fun story was that they gave me demo units. So
empty.
I'm coming through the airport with my bag full of landmines. And the funny thing was that they didn't care. They went through, this is pre 9/11, and they didn't even ask me a question. The bag.
I guess they had never seen
full,
one, right?
Of course, they'd never seen it before, but these were real landmines. They were disarmed, obviously. They didn't have, any TNT in them, but they were real landmines. And that's fine. Keep going. Keep it moving. And so anyway, we got back to MIT, and one of the things that I was proud of at the time was that I let it be known that I knew nothing about landmines before the class started. I intentionally avoided teaching myself. I didn't read anything. I wanted to be as cold as the students going in because it was a class on invention. And if I knew anything, I thought I would invent something and then I would steer. I didn't want to steer. I wanted a pure experience. And so first day of class, sitting around, and I said, I know nothing about the subject, and we're going to learn it together. And so going to Fort Belvoir was the key part of that. And so it was great. We had a great class. I think it was a really positive experience. It was a great first teaching experience for me. I think the students learned a lot. Unfortunately, I taught it again the next year, and anyway, the fortunate part is that I now knew about the subject. I can't unlearn. So the second year, it was more about exploring for the students, and I had to turn off that part of me and not steer, and just let them, have an idea, great idea, and play the role of not knowing, and let them go through the process. And I'm pleased to say that we did come up with one thing that's still used today that became a standard for humanitarian demining, an important contribution. And they contacted us and said, what do we owe MIT if we want to make a product and make this commercial? And I just said, just call it the MIT Prodder. Just give us name recognition. We don't want anything. And so they still call it that. So the MIT Prodder is it's very simple. I mean, it's a beautiful solution. Instead of using a round stick, because I didn't explain how it works, but you use a stick in the dirt. That's about as complicated as
a long stick, I hope.
18 inches.
Oh, you're pretty close to the mine.
Oh, you're very close. Yeah. But the idea is that you have to do it at, if mines are this big, you put the sticks every that much. I mean, when I said you have to be thorough, you have to be incredibly thorough. This is a very slow, tedious, lengthy process. And at the end of the process, to let you know how thorough it is, the way that you inform the village that the field is now safe is that the deminers, the team of deminers who did all the work for the last few months, play soccer in the field. That's the test. So that's also the motivation while they're doing it. They know that when this field is done, they're going to be playing soccer in that field. And so anyway, the stick, instead of using a round stick, we had an oval. And it makes a huge difference. Because now when you put the stick in, if you try to put a stick into the ground, the deeper it gets, the harder it is to push. And if you have a mine under that, you want very controlled motion. If you have an oval cross-section, put in a little bit, you turn it a little bit, and you compact the soil on the sides, and now you have room. And now the stick goes in cleanly. Turn it a little bit, you have room. And now you have complete control. You're not pushing against the friction of the ground. Very simple. It's elegant. It costs more to do. I mean, it would cost more than, once you had, they made a form so they would extrude this oval shape. Very, very proud that the team came up with that.
Okay. I found that I looked at all your patents. I mean, I searched for your patents, and quite a few fall into the MIT time, including for automatic test equipment. Was that for a semiconductor test?
Yes.
Huh.
Yeah. My professor at the time was precision engineering was his area, Alex Slocum. And he's the god of precision engineering on this planet. And so he was working on semiconductor test, which is an area of very high precision. And so as part of that team, I came up with some ideas and ended up being patented.
And you got an award as for a student inventor.
Yeah, the Lemelson MIT Student Prize, or prize in general, was new. I think my year was the second year. And at that point, I had numerous patents and licenses. I had a few licenses. I think I already had the Palo's license at that point. And kryptonite, I had a kryptonite license, and I had the Scotch or BASF license. And I was sort of the archetypical inventor. A lot of the inventors had one project, very, very high tech, somewhat inaccessible. And I think I was an obvious choice for an early Lemelson winner because my inventions were very simple and very accessible and very commercial. And so, yeah, so I won the student prize. And it was $25,000 or $30,000. And it's very nice.
Yeah, for a grad student.
Yeah, absolutely.
Yeah.
Graduate student then, right?
Yes.
I mean, I'm guessing that in the last 30 years, it's another, maybe a factor of 2. So it's the equivalent of maybe 50 today.
And one of your patents I saw was for a changeable tattoo. Do you have one that you can show us?
No. At that point, I was very much into pure commercialism. I just was looking where the money was. Tattoos were an area of clearly growth industry. And e-ink
was big.
Was new.
It was new, yeah.
And an obvious thing to do would be to implant e-ink. And then the question is, what can you do with implanted e-ink? And how would that work? And so there was it was an area for invention there. So I patented the idea of changeable tattoos. And one of the things I thought would be the sexiest, I couldn't think of another way to do it, but if you had a mylar or indium tin oxide on a clear plastic sheet, and you put that over the tattoo, you could have movable tattoos. You could have cartoon tattoos that would change. Your skin would actually change. But the original concept was just you could wake up in the morning, you'd have a printer, your skin printer, and you would put this thing on your arm or wherever the tattoo was, and you could print
today's tattoo.
To do today's tattoo. And it would stay there for the rest of your life if you wanted it to, or you could change it 5 minutes later and it would stay there for the rest of your life. And I still think it's a very interesting concept. And every few years, someone on Wired or someone reinvents it. But I definitely have the earliest patent on the idea.
Did you license it?
I was approached by a few different companies over the years. When some Israeli company wanted to do it, and I forget why I ended up not licensing to them. But I never did it. I think it was, there's a lot of work to putting a new material into the body. I think tattoo ink, I believe, is not regulated, and I could have slid underneath
But
that
this
wire.
would be probably
Exactly.
it would be micron-sized balls.
Yeah,
which
yeah. So the answer is I
seems a bit
never
dangerous
did.
to have 'em.
I never did anything commercial with it. Never licensed it. Never did it to myself. Certainly, I don't have any tattoos. It was one of these cases where I had no interest in tattoos myself. It was purely.
You didn't test it on yourself.
I just saw dollar signs and thought this was an interesting area for innovation.
Wow. And so around that time, the New Yorker got wind of you and interviewed you?
Yeah. I think the Lemelson Prize. It was winning the Lemelson Prize that got some attention.
Okay.
And so I got interviewed by New Yorker and Fortune. And someone wanted to do a TV series. And that was fun. It was
About inventors? Or?
It was a plot for like a sitcom. And I would have been the archetype of whoever it was, right? It would be about me. And so it was in conversations with us. The idea was an inventor, right? It was an idea of the main character being it was an inventor. And they liked the Fortune article. No, I'm sorry. I think they liked the New Yorker article. And they were going to base a character on that. It obviously never happened, but it was fun to talk about.
Okay, so what was your next venture after leaving MIT?
So I taught this class, and about then got a job with Arthur D. Little, and ended up working on a very small team there, 3 or 4 people, and it was their intellectual property group. And the raison d'etre of that group was to find meaningful IP in the world and to maximize its value. So people would come to them. Sometimes inventors had already gotten ripped off by some company, and they didn't have the wherewithal to fight themselves. And they would come to ADL and say, "Help me," and we would. Okay. I haven't decided there's any confidentiality around this. I'm going to say it's old enough that I don't think that, even if there was at the time, it's gone. But so the inventor of the blue strip on razors, there's a wear strip.
I have an electric razor. I don't know.
There's a wear strip on a manual bladed razor. And a company that shall be nameless stole the idea from this inventor. He had shown them the idea. They said, not interested, and they ended up doing it. And so he couldn't fight them.
And he had patented.
He had a patent, yeah. And he couldn't fight them by himself. So he worked with us, and we picked up the gauntlet, and we won his case. And got him millions of dollars. And got us millions of dollars. So that's the kind of thing we were doing. And then also I would go around, ADL was an amazing company. It was a 130-year-old company at that point. Arthur D. Little was an MIT grad who invented consulting. He had this amazing idea that instead of a company having employees within, that he would rent them his workers. That was his concept. And so by the time I had joined, it was a bunch of Ph.D.s that would consult on technical projects. And so I would go around ADL, and we would do inventing internally. So instead of just taking outside IP, we would generate it internally. And so I played the role of helping. I would manage groups. We would have lunches every day and bring in food and just sit around the table with ADL employees and invent. And it was fun.
Oh,
And
employees from all over the company? Or?
yeah, well, it's a fairly small company with maybe 200 people, I'm guessing. It was an unusual.
But not just your group.
No. It was like all 200.
Okay.
We would just go from group to group to group to group around ADL. And but yeah, it's the whole company over time. And and also part of my job was to filter through ideas from outside ADL. So we would just get submissions. We had a standing on the web to submit your ideas, and a lot of those places are fake. A lot of those places are rip-off places where they want you to pay to have your idea evaluated. We would give them $1,000 and they'll do something for you, supposedly. That's not what ADL. ADL was one of the few legitimate sources. We wouldn't take any money. And if the idea was worth pursuing, then we would put together a deal with the inventor and we would pursue it. So part of my job title was just going through submissions one after another and looking at them from manufacturability and strength of the IP. So we would do patent searching. And so yeah, I was there for a few years. And it was then that I went on this trip with Shiguang and decided that I needed to leave ADL and start my new company. And that's the transition. That's what made me leave ADL. It ended up being just as good. The company didn't survive much longer after I left. After 130 years.
Oh, really?
The company died soon thereafter. Yeah.
It seems to me kind of stand-on name. I mean, I certainly recognize the name. They're gone, huh?
It's A.D. Little is a accounting firm. Arthur D. Little.
Oh, okay.
They have no connection. It's an unfortunate. Yeah, they're just two men's names who happen to be similar.
Oh, it's not even the same founder.
No, not even. No.
Okay.
Yeah, no. Arthur D. Little was is a high-tech consulting. They tried to do management consulting. Became a hot thing in the 80s, and Arthur D. Little didn't transition well from pure technological consulting, which he did very, very well, to management consulting.
Okay.
Different
in
people,
my mind,
different
I just
skill
connected the accountants with you also do consulting, right?
No.
Okay.
No, different group, and AD Little may still be around. Don't know, but
I kind of think they are, but I have no use for their services.
No, nor I. But yeah, so that was the transition point from being a worker bee to being an entrepreneur, and I've not worked for anyone else since then.
So we already covered the Digit, your company, and from what I saw of the timeline, there was a few years between selling that and starting or getting into another company. What did you do in that time?
I was badly burned out after Digit Wireless. It was my first startup, and I had didn't know you could work that hard. There was long periods where I was working 7 days a week, 12, 14 hours a day. Long periods of just not stopping, going to sleep, waking up and starting again, working continuously until you go to sleep, and doing that without stop, without weekends, without anything for months. And did that in some form for almost a decade. It wasn't that extreme for the decade, but multiple years of that, and it was following the dream. I mean, there's a lot of work that needed to get done, and as the founder, back and forth between being CEO or not being CEO, I knew where all the bodies were buried and ended up doing lots of different jobs. And if something needed to get done, I would go do it. And the idea of it succeeding, at the time I had this concept of, I was a juggler. And so at the time I had this concept of juggling life. You sort of you can't stop. If you're a juggler, as soon as you stop doing it, they fall down and you fail. So the idea of being in a startup to me was you throw the balls up so high. This is this trick in juggling where you throw the balls up and you do a spin and you come back and you catch them. Well, conceptually, if you throw them up so high they enter the atmosphere, you can walk away and you're still juggling and you're no longer needed. And that, conceptually, the idea of doing a lot of work and being so successful at juggling that your life, you could walk away and do anything you wanted and have a dream life of being a multimillionaire, that was what I was working for. It was easy to think that I was just going to burn the candle at both ends for a few years and then never have to work again. And that was enough motivation. And it didn't work out, but at the end of it, I had the burnout of a lifetime of work. And so for a few years, I decided to move to California, which is home to me. I had lived in Boston at that point for 20 years and hated every year of it.
Especially in winter, I assume?
The winters. Boston's a fine place. I like Boston, the city. But I'm from Los Angeles, and so every winter I would say, this is my last winter. Next winter, this is my last winter. I would do that over and over and over again. And so when the company was sold, I was out of there. And so I looked and made a chart and looked at different places on the planet and different places in California and decided I wanted to be in Berkeley, and moved and bought a house and spent some time fixing it up and exercising again and relaxing. I had some money from selling the company, and not enough, not enough to stop working, but enough that I could take a break and recuperated.
And now you're running a company again.
Yeah, so at that point, I had some money, and my friend Shigong, so this is coming back into the circle, had a new idea. He had a previous idea that had done very, very well. And he had this new idea for G protein coupled receptors and how to solubilize them and do something. He didn't know what at the time. He had different ideas on what he would do with them. And asked me to be an investor.
This is bioengineering field,
Yeah.
I guess. Okay.
Yeah. So I made an investment in his company, and after having made the investment, I got deeper into the details. I initially made it largely based on knowing him. Great guy, brilliant, very successful at the company. So I made the investment and then found out that there were some problems.
Afterwards.
Yeah. And partly to protect Shigong. Part of the problems was that Shigong was being taken advantage of. So partly to protect him and partly to protect my investment, I ended up playing a role in the company. And that role got larger and larger over time. And so I ended up being running the company. And that became, it's not a full-time job, but it's, we've raised several $1 million, and it's a lot of work.
Are you back to burning the candle at both ends?
No.
Okay.
No, I'm much more civilized. Now, I think I could still. I just choose not to. I'm smarter than that now. I think it's just it's self-abusive, and I don't feel the desire, So, yeah, I think I went through a very long period of my life where there was no balance whatsoever. And I'm not telling anything to many, many, many people in Silicon Valley. It's a very, very old story around here. But I'm not completely cured, but I have a lot of balance that I didn't for that decade and sometime past that.
Good. Okay. I guess we covered life-work balance. As a final subject, would you recommend the life of an independent inventor to people about to graduate from college or to young people in general?
If you have a time machine, yes. If you can do it 20 years ago, absolutely. It was it's a pure. The reason I got into it in the beginning continued to have the value to it, which was that there's romance to intellectual property to me. I don't see much of a difference between writing a book or doing music or any other intellectual pursuit. You're creating intellectual property. You're making something of value from your mind and your heart. You have some thought, and that thought becomes what you live on. It becomes how you eat food and how you care for the people in your life. It's through the purity of thought. There's a beauty to that. And I'm not a musician. Wish I was. Writing as a profession terrifies me. I enjoy it, but I don't think I can do that. But the intellectual pursuit of just thinking of ideas and being an engineer and creating products brings so many things together that are practical and useful and can be beautiful. And all those things appeal to me. And the kernel of it is the concept, the invention itself, and the reason it's protected, the reason it's yours is the intellectual property. Like, you can have a good product, but if it's a really good product, someone's going to steal it. That's where the IP comes in. But the reason I think you want a time machine is because being a pure inventor today is next to impossible. It's very, very difficult. The America Invents Act hurt independent inventors somewhat. It wasn't a killer. I don't want to over-dramatize the negative impact of AIA. But
it aligned the law with the rest of the world.
Yeah. In itself, that's not a good thing. I mean, I don't see a benefit. Yeah, abstractly, it's nice to be the same, but I think the notion of first to invent being the guideline is sort of what it should be, right? If you were just going to create the world, the rest of the world, the reason first to file is good is because it's easier.
Right.
It doesn't mean it's better.
It's
It's easier.
documentable.
Yeah.
And there is
It's simpler.
less leeway for the lawyers
Exactly.
to fight.
That doesn't mean it's the right thing to do. So, yeah, I appreciate the simplicity of it, and harmonization is a good thing, but you've degraded invention in the sense that being first to think of the idea is no longer the criteria. Now it's first to have enough money to get to the office. And it puts independent inventors at a disadvantage. The provisional patent, which existed already, is a saving grace that helps tremendously and ameliorates the problem of having a first-to-file system. The bigger problem today is that I think the bigger problem is that the R&D departments of a lot of companies are smaller than they used to be. So if you come up with an idea and you go to a XYZ company and you say, I have this idea, it's fantastic, you guys should look at it and take that ball and run with it. They look at it and go, we don't know what to do with this. You go away, you develop it. When you have something, you have a really good prototype or even a product, not even just a prototype. A lot of times they want solid product. They want sales. They want sales numbers. They want you to bring it all the way to the end, and then they're happier to buy your company for multi-million dollars than they are to take your concept for fractions of a penny, but they do the work. That's the change that happened. Once upon a time, like I had Panasonic. I had an idea for an ergonomic thumb wheel, Panasonic, and it was a nautilus shape. Instead of having a volume control be a circle, make it a nautilus shape. That was the patent. The whole idea. So it's loud, it sticks out far. If it's quiet, it only sticks out a little bit. That's it. It's elegant. It's simple. What am I going to do with it? What, am I going to make a Walkman and in order to show off my thumb wheel? Makes no sense. So they made me an offer for that, $20,000. Fantastic. End of story. If I did that today, I predict there's no chance whatsoever that a company would be interested in an idea like that. Those doors are closed, and so now there's a new model for being an inventor. It's a much harder model. You have to make products, which is, I don't think it's a bad model, because I enjoy all this part of the process. But if you want to be a pure inventor, which is what I originally conceived myself to be, of someone who wakes up in the morning and thinks of something, patents it, and licenses it, and goes on to the next thing. That was the business model. That model may not exist anymore. So the current model is you invent something, you make a prototype, you get enough funding. There's many funding sources now that didn't exist back then. You make it, and once
you do a startup, probably?
You do a startup, and GoFundMe, and use all those sources, and you make a product, and you make a company, and you have a startup. And it's years of work instead of weeks. And instead of looking at tens of thousands, you're looking at millions. But instead of doing tens or hundreds of different things, you're doing one thing. And it's a completely different life. And it's just different. But my original career that I had chosen for myself, I don't think it exists anymore.
I hadn't thought of that I mean, your point is that it's the drying up of corporate R&D that starves the individual
I don't have
inventor.
any proof of that.
I can see your point. I worked in R&D all my career, and it is, I mean, it is
I believe,
shrinking
yeah,
because it's
anecdotal.
it's hard to
yeah.
measure, and so it doesn't get the funding because it's not a source of profit. It's a cost, and it's hard to convince people that this is going to be something big in 3 years from now or 5.
It's very, very difficult to imagine a manager walking in to talk to his team and saying, you people are screwing up because you're succeeding. It was weird then. It's impossible to imagine today. I just can't picture it. You know, companies that have true R&D departments that are really just looking at crazy things that are out there. I mean, there was Xerox PARC. You know, there was IBM Almaden. You know, there were groups that really were looking at what could be. I don't know if that happens now. I mean, certainly looking at a few years, looking out 3 years, but not looking out
like
10
that.
years.
Yeah.
Right. Who looks out 10 years?
Yeah. Okay. Thank you very much again. That was a great experience for me.
It was fun. Yeah, thank you.